When considering the rising prevalence of obesity, it's tempting to assume that personal behavior is the only factor, an oversimplified view that often blames individuals for poor choices. However, this perspective neglects a deeper biological truth. Not all bodies respond to food and activity in the same way. Genetic predisposition plays a powerful, though often misunderstood, role in determining how much fat the body stores, how easily it is burned, and how hunger or satiety is experienced. Combined with the emerging science of epigenetics, the way environmental factors can influence how genes are expressed, this explains why some individuals gain weight more easily than others, even when their lifestyle appears comparable. Obesity is a highly heritable trait. Twin and family studies suggest that 40 to 70% of a person's tendency to gain weight is influenced by genetic factors. This doesn't mean there is a single obesity gene, but rather a constellation of genes that affect appetite regulation, energy expenditure, fat storage, metabolism, and even how the brain responds to food. For instance, the FTO gene, one of the most well-studied in relation to obesity, is associated with increased hunger, preference for high-calorie foods, and reduced feelings of fullness. People with certain variants of this gene are more likely to consume larger meals and gain weight more easily, not because they lack willpower, but because their biology is pushing them toward a different baseline. Yet genetics alone cannot explain the dramatic increase in obesity over recent decades. Human genes have not changed significantly in that time, but the environment has, particularly the food environment, physical activity patterns, sleep, stress, and exposure to pollutants. This is where epigenetics becomes crucial. Epigenetics refers to the way genes can be turned on or off in response to environmental stimuli. Certain behaviors or exposures, such as poor diet, chronic stress, lack of sleep, or even a mother's health during pregnancy, can leave chemical marks on DNA that affect how genes are expressed. These changes do not alter the genetic code itself, but they can significantly influence metabolism, insulin sensitivity, and fat storage across the lifespan, and even across generations. For example, prenatal undernutrition or maternal obesity can influence the development of fat cells in the fetus, increase the risk of insulin resistance, and predispose a child to weight gain later in life. This means that a person may be born into a body that is already primed to store fat more efficiently, even before they make a single dietary choice. Early life exposures, such as high-sugar diets, lack of breastfeeding, antibiotic use, or poor sleep, can further modify the expression of metabolic genes. These epigenetic changes can make it harder to feel full, easier to gain weight, and more difficult to lose it, even with a healthy lifestyle. This doesn't mean that genetics or epigenetics doom anyone to obesity. Rather, they set a range of possibilities, what scientists call a genetic potential, which is then shaped by the environment. For some, the threshold for weight gain is lower. For others, appetite regulation is less precise. In a different environment, such as one with regular physical labor, limited processed food, and consistent sleep, these predispositions might remain dormant. But in a modern environment filled with calorie-dense food, stress, and constant stimulation, they are more likely to be activated. One of the most sobering aspects of epigenetics is that some of these changes may be passed on to future generations. A person exposed to famine, toxins, or metabolic stress can pass epigenetic markers to their children that affect how those children metabolize food or regulate appetite. This raises a serious public health concern. The consequences of today's food environment may ripple forward, making it even harder for future generations to maintain a healthy weight, even if they grow up in more supportive conditions. The key takeaway is that body weight is not solely about individual responsibility, it is about how a person's biology interacts with their environment. For those with strong genetic or epigenetic predispositions, maintaining a healthy weight may require more effort, more structure, and more support. These individuals are not weaker or less committed, they are operating under a different biological set of rules. Their hunger may be stronger, their satiety slower, their fat cells more efficient at storage, and their metabolic responses more resistant to typical weight loss strategies. Knowing this can be both sobering and empowering. It challenges the stigma around obesity by revealing how deeply unfair it is to assume that all weight gain stems from personal failure. At the same time, it highlights the need for personalized approaches to weight management that go beyond one-size-fits-all diets or advice. Strategies like regulating blood sugar, prioritizing protein and fiber, managing stress, and ensuring consistent sleep become even more critical when biology is working against you. Medications and medical support, often judged or stigmatized, may be not only helpful, but necessary for people whose genetic expression resists weight loss. On a broader scale, understanding genetic and epigenetic influences underscores the need for structural changes. Environments that reduce stress, promote activity, limit ultra-processed foods, and support healthy pregnancy and early childhood nutrition are not just good ideas. They are essential strategies to prevent the activation of obesogenic gene patterns in entire populations. Obesity, therefore, is not simply about choice. It is about biology shaped by history, environment, and inheritance. A compassionate, science-informed approach recognizes that while we cannot change our genes, we can change our surroundings, our strategies, and our expectations. Supporting people in their struggle with weight means acknowledging the invisible burden of genetic predisposition and helping them lift it with understanding, not judgment.